So without further ado, I'm going to introduce our first presenter. It's Matias Turkulainen. He's an MSc student interested in the intersection of computer graphics and computer vision. Matias is soon to graduate in robotics from ETH Zurich and is pursuing a PhD with Juno Kannelin, exploring new geometry representations for 3D reconstruction with applications in computer vision problems. He's an active open source developer, and he is one of the 6 maintainers of Nerfstudio. So please take it away, Matias.
Yeah, thanks for the grandiose introduction, Mike. Hopefully you can hear me okay. I've had a bit of been a bit sick recently, so hopefully my voice is not too monotone from what it is usually. Let me know if you guys can see my screen. I should be presenting at the moment. Can anyone put a thumbs up? Yep.
Yes.
Cool. Great. Okay, without further ado, I'll get started. So yeah, my name is Matias, and Felix kindly asked me to join this meeting to give a short introduction to this open source project called Nerfstudio. So that's pretty much what my presentation is about. I'll just give a quick overview of what Nerfstudio is and what kind of tooling it provides for both kind of nerfs and Gaussian splatting. And at the end, there's a time for some Q&A. So if you have any general questions or technical questions, I can try my best to answer you. So yeah, without further ado, I'll try and get started my presentation. So I'll start off with just some general stuff about me. I'm pretty much just a student interested in computer vision, programming, and technology in general. And during the past year or so, I've had kind of like my main hobby has just been following this Nerfstudio project and trying to develop it on GitHub. So if you're interested at any point during this presentation about this stuff, you should Google Nerfstudio and you'll find a lot of tutorials and documentation and things that I can't really kind of cover in a short presentation. So yeah, what is Nerfstudio? Nerfstudio is an open source project that began from a group of researchers at UC Berkeley Bear Lab, led by people like Matthew Tankik and Professor Andrew Kanazawa. And during the past 2 years or so, it has kind of blown up or been actively developed on GitHub. It has over 200 unique contributors at the moment and many thousands of lines, if not even close to 1 million now, lines of code. And personally, I'm coming more from kind of academic background, so I only know the use cases in research, but I hear people are also using it for commercial things like startups and stuff like that. So before I talk too much about Nerfstudio, I want to give a quick overview of what was out there before Nerfstudio. Everything kind of started with the ECCV paper in 2020, representing neuroradiance fields by Mildenhall and Tankik and et al. And this paper really inspired the research community with a lot of derivative works, kind of improving the algorithmic sides of nerfs and applying it to different fields like robotics and like VR and stuff like that. And during the same time after 2020, a lot of open source projects came about, and a few famous ones that were kind of around before Nerfstudio. For example, this project NerfPL and NGPPL by Quail123, which were basically kind of easier, more modular re-implementations of the original Nerf algorithm, and also this algorithm called InstantNGP from NVIDIA. And this project was quite influential, kind of like within the research community. Similarly, there's this project called TorchNGP that kind of does the same thing, kind of re-implements these algorithms in a more Python and user-friendly format. And this was also used in many quite famous kind of like research projects as like forks and stuff like that. And this is kind of where Nerfstudio came from. It kind of saw this need for an easy modular, easy to develop library for all the various nerf related research that were coming out at the time after 2020 and ever since pretty much. So Nerfstudio started around, I'm not entirely sure about the exact dates, but around March 2022 or April 2022, so a bit over 2 years ago now. And I only learned about it after around a year and a half ago that I kind of started working on Nerfstudio and getting familiar with the project, and then eventually kind of building more and more code for it. So what is Nerfstudio? Nerfstudio is this huge project on GitHub. It's kind of like a library at the moment, which implements various different building blocks of the whole end-to-end nerf or Gaussian splatting framework. So one big thing is like starting out with raw data. So things that you capture with your own mobile phone or camera or downloaded data set from the internet. And you have to kind of process these into some sort of suitable format, which basically means solving for like the camera calibration for your images or video that you're dealing with. Then it implements this sort of real-time web-based viewer called Visor, and I'll talk about this a bit more in the next slide. And then it also implements a lot of various kind of post-processing scripts to take a trained model and convert it into some other format. For example, you can create these sort of trajectories and render videos out of them, or you can kind of generate point clouds or meshes or other sort of geometric primitives from your kind of trained model. And the main meat of Nerfstudio is really in this part on the left where it's labeled like samplers, fields, encoders, and renderers. And this is kind of like where all the different research papers have been focusing on. For example, the original Nerf paper used this sort of like uniform sampling method to sample a long array. But then papers that came out after the original Nerf paper improved on this sampling strategy with like inspiration from computer graphics, like PDF-based sampling. Or for example, Instant NGP did this kind of occupancy grid-based hierarchical sampling thing. And then a lot of the meat of like nerfs or Gaussian splatting is kind of like in the encoding or in the field part, which is basically the differentiable elements of your kind of training and analysis by synthesis, analysis by synthesis method. So this has all like the small neural networks and kind of encoding parts. Nerfstudio also has different types of like visual outputs. So there, like Nerf is mainly for like the RGB channel, but you can also visualize the depth channel, like the set buffer, or also things like accumulation maps, which is like the transparency from the volume rendering equation, or normals. So that's like a basic overview of Nerfstudio. It's just like a huge library which implements pre-processing, post-processing, and also a lot of these algorithmic details within different kind of Nerf or Gaussian splatting based methods. So if you're a new user to Nerfstudio, basically the overall pipeline that you follow to go from like your data to like an output is as follows. First step is like to pre-process your data. So you've captured some data with your phone and you have to convert it to some suitable format that Nerfstudio can ingest. And you can do this everything from the command line with a few commands. If you're familiar with like, if you're coming from industry and you're familiar with things like Metashape or reality capture, these things will be kind of familiar to you. But there's also a lot of pre-processing stuff that's open source like Colmap. Then the next step is kind of training your model, and Nerfstudio has a bunch of different model variants that you can choose from, and I'll talk about this a bit later. And then lastly, you can view your model, export your model, or render like a cool video out of your model. And if you're a developer, developing around Nerfstudio is super nice because of the main thing that Nerfstudio implements, which is like these tools or different like user-friendly Python-based tools for kind of Nerf or Gaussian splatting development. This includes really basic things just like tracking your training metrics with like 1B or TensorBoard. There's also like this new web UI based Gradio thing that if you don't want to use the command line, you can also use this like point and click based user interface for Nerfstudio. And the main kind of interesting thing from Nerfstudio that's missing in many other open source projects is like a good visualizer, or a tool that lets you view the training process in real time in 3D, and also look at it after you've trained it and export it into some other format. So the viewer is this other project called Visor, and it's developed by Brent Yu. And it's basically a JavaScript library with Python front end. So it's a lot more modular and user-friendly. And it's not only for visualizing nerfs or Gaussian splats, but it's also for other things. For example, you can render and visualize like other geometric primitives like meshes or point clouds, and it's like all programmable. So you can write these little functions that like end up being little buttons on the screen, and you can kind of program them to do different things if you're interested in that. Yeah, and the main meat of Nerfstudio is all the various methods it implements. And at the moment, there's just like a huge list of different integrated methods and third-party methods. So it's not possible to kind of give an overview of all of them, but the main methods that Nerfstudio supports at the moment is this nerf-based model called Nerfacto, which is basically an amalgamation of different research papers into one nerf-based model. And then now there's also this recent kind of like Gaussian splatting based model called Splatfacto, which implements kind of ideas from a few Gaussian splatting based research papers. Then there's also other older methods like the Instant NGP from NVIDIA, the original nerf model, and these other kind of interesting ones like MakeNerf 360 from Google, and like Generafacto, which is like a generative model based on, I think, Dream Fusion, which came out, I think, also 2023 or something. So yeah, here's like a basic visualization of Nerfacto, which is like the nerf-based model in Nerfstudio, what it looks like in the 3D viewer. I think this demo is a bit old, so the visualizer has changed a bit since, but you get the basic idea of it. So with Nerfstudio, you can train a nerf or Gaussian splatting thing, and you can also use the various tools to kind of export renders or kind of meshes and stuff like that from your nerf. And this is, for example, an output video that you can get using Nerfacto. Yeah, and there are many other methods out there as well. Here's some cool visuals of things that have been collected over the years. There's like implementations of like these nerfs underwater called see-through nerf. There's some user that created like a nerf from Mars, from collected images of satellite Mars data. And there's like a demo or like a YouTube video. I forgot what artist made this on the bottom right, but it was on YouTube, this music video that featured like nerfs for the first time. Nerfstudio is also used in quite a few research projects, basically mainly because of the good tooling around Nerfstudio. So the visualizer and all the different kind of algorithmic things that have been implemented in Python have been very useful for other people. So people have kind of developed external methods based on Nerfstudio. Here are a few examples of them. Yeah, and since this is a Gaussian splatting meetup, I'll end my talk with just stuff about Gaussian splatting. So credit where credit is due. I guess the whole hype started with another research paper. It's kind of reminiscent of the whole nerf thing from ECCV 2020. I guess this is SIGGRAPH 2023, a paper by the GraphDeco team from NVIDIA, from Bernard Kerbo, Georgios Kapanos, and George Jatakis's team developed this new sort of radiance field representation, which is differentiable, but is faster to render than nerf. And it's been quite influential ever since. So kind of like the theme from 2020 is kind of repeating again in 2023 or 2024 with like a bunch of new derivative works based on Gaussian splatting in different fields. Algorithmic improvements are like occurring at the moment, which has been really interesting to kind of follow. So here's a quick overview. If you're not so familiar with like technicalities of what is a nerf and what is a Gaussian splatting, but basically there are two different methods that apply something called the volume rendering equation, which is kind of like a physically based image formation model. But nerf on the left does it like based on samples along array and using a small kind of neural network to output estimates of color and opacity. And the Gaussian splatting variant takes away this idea of samples and replaces them with like discrete samples along a viewing direction, which are represented by these kind of 3D shapes, Gaussian kernels, basically. And it takes away the sampling stage and just does this basically point projection or rasterization, they call it in the original work, where you just bring all these splats into the image and you compose them using the volume rendering equation or discrete volume rendering equation. And there's a small difference about nerf and Gaussian splatting as well, is the way that they treat color. In the original nerf papers, color is usually encoded by some sort of neural network, but in Gaussian splatting, color is encoded on these like balls, which are called like spherical harmonics. It's basically like a sine, cosine, Fourier encoding of color. And Nerfstudio basically has now re-implemented the original 3D Gaussian splatting method. So you can use it inside Nerfstudio and visualize it and train like Gaussian splats, just like you would in Nerfacto, for example. And this is kind of an active project being developed at the moment. It's open source and has a pretty nice Apache 2.0 license. And it kind of also takes inspiration from Nerfstudio and tries to do everything kind of in a modular Pythonic way, and tries to do it in a developer friendly way as well. So it's easier to add new ideas or new kind of research projects into the original code base. And it's recently been used in a few nice research projects that have come out. For example, in NeurIPS just recently, or before that, like at ICCB and stuff like that. And I have even heard that a few startups are using the open source code base for their kind of 3D asset generation, stuff like that. So yeah, that's pretty much my presentation. Here's like a small visual of what you can expect from Nerfstudio at the moment. Cool visual of like, I think Justin Kerr recorded this data set somewhere and create a splat from it. Yeah, so that's pretty much it. So I'm free to take any questions now.
Hey, Matias, thanks so much for your presentation. We've got a lot of questions in the chat. I don't know whether I'll be able to get to all of them in the time we have, but let me just pick a couple.
Yeah, go ahead.
The first one was what Colmap-free models are available to improve the initialization phase of Gaussian splatting?
Right. So I assume you're referring to kind of like the oops.
Yeah, I think the question is maybe about what alternatives to Colmap are there for the pre-processing stage. I think.
Yeah, I had a huge list of those. So Colmap is this kind of open source project from ETH for structure for motion or camera calibration, but Nerfstudio also supports various other more industry friendly or app-based kind of camera calibration software. For example, if you have an iPhone, it supports Polycam and also this other app called Spectacular AI to get your camera intrinsics and intrinsics. And if you're more like an industry user, we have support for like Metashape and reality capture and all these kind of more beefy software stacks that are kind of like more industry based. I'm not like too familiar with all of them, to be honest.
Okay, thanks. And another question, which I think we've heard a lot, is will Nerfstudio run on Mac OS?
Right. I guess it already kind of does run on Mac OS, but the problem with developing on Mac is the dependency on CUDA. So at the moment, everything that makes like training fast, so not the rendering part, so not after you've trained a model and you're trying to view the model, but the training part of the whole process is quite dependent on the software called CUDA, and it's kind of like an NVIDIA kind of not really proprietary software, but it's like this huge library or pieces of API for GPU programming, and everything in Nerfstudio and nerfs and Gaussian splatting is for the training phase is really optimized for kind of differentiability, which is done on GPUs and stuff like that. So like doing the training on a Mac is, for example, you can do it if you want to only use PyTorch. Because at the moment, PyTorch 2 point something supports macOS on Silicon. So you can basically do the training part also in PyTorch, but you would miss out on the CUDA acceleration. So it would probably take you days to train a Nerfacto model, for example, when it would take a few minutes, even on like a commercial based GPU, like a gaming graphics card, for example. You can train Nerfacto in maybe 30 minutes, 40 minutes, and Gaussian splatting around the same amount of time as well.
Cool.
But then there's the visualization part of it. For example, the moment Gaussian splatting, the final rendering part is not dependent on CUDA anymore. So once you've trained your model, you've done like scene reconstruction, you can actually render it in real time on any device, CPU bound or even WebGL or WebGPU based.
Okay, thanks. I'm looking through the Q&A. Your talk has really sparked a lot of questions, and I know unfortunately we're not going to be able to get to all of them, but maybe is it okay if people follow up with you with questions later? Or is that okay? Is that okay with you?
Yeah, definitely.
Okay, and then I'll just grab just a couple others before we move on. Another one was, are there any plans to support? Sorry, I thought it'd come up there. Are there any? There's so many questions. Are there any plans to support 4D Gaussian splatting in Nerfstudio?
Right, yeah, that's something I'm quite interested in as well, but from my side, I can't really say anything about that. I don't know. I don't know if anyone else is working on that. I would like to work on that, but it's kind of it's quite a difficult. It's also kind of research based at the moment, so it's definitely not easy to kind of start supporting rendering or training for these scenes because it's quite yeah. I guess in the future, I'm certain it will in some format be supported. There's I already know of a paper that uses Nerfstudio Gsplat backend to do 4D based Gaussian splatting, and that will probably be released at some point on GitHub and stuff like that. So people are definitely working on it, but I'm not sure if it's going to be like part of Nerfstudio officially, or it's just going to be someone else's research project or something like that.
Another thing that I've heard spoken about in many forums, and it's come up here in a question from Yoshi Sato, and that is Gaussian splatting being open licensed? Does that mean that companies and businesses do not have to pay a licensing fee to the original 3DGS authors in RIA?
Yeah, I really don't want to get in trouble for saying something that I don't know too much about. I'm just a random kid on the internet pretty much. But from my understanding, an Apache 2.0 license means that any startup or company can use the code freely for their product commercialization.
Okay.
And at the moment, Gsplat, which is the Nerfstudio reimplementation of 3D Gaussian splatting, is Apache 2.0 license.
Okay, so I'll add the caveat that none of us here are lawyers, I think, so that you should seek your own legal advice regarding intellectual property. I'll just throw that in there. And I think that's the end of the questions that we can get to today. thanks so much for your talk. It was really fascinating, and based on the number of questions, I think there's a lot of follow-ups that people want to do. So expect to be bombarded. Thanks so much, Matias.